This week we're talking about evaluating research and how to create research questions and hypotheses. To start, one of the things that we're trying to do is to be precise in the way we think about how variables interact with one another. And one of the ways we can do that is getting down to how we measure things. So precision is very useful when we start talking about doing research. We want to be accurate in our measure, and we want to be precise with our measure. Sometimes we can be one and not the other, and sometimes we can be none of them, and sometimes we can be both. Just because I can be consistent doesn't mean I'm actually hitting the target. So if we have poor measurement of the variables that we are talking about, then our statements about the world are not going to be very useful because we're not actually measuring the thing that we're looking for. Another concept that is sometimes difficult to take in is this idea of power. So we want our research to be powerful. And what we mean by that is that we want to have both conceptual and methodological power. So conceptual power comes down to definitions that are useful, they give insight about the ideas, and get down to the small details. They may be more precise than what would be a layperson definition. And that allows us to get precise in the way we think about it, and therefore we get precise in the way we can measure and talk about how it interacts with other parts of the world around us. Now, methodological power comes down to how well we select our data. So if our concept is very precise, then we have good conceptual power, and then we go attempt to gather data about that idea. We are already starting off ahead, and then we can continue to do a good job by gathering our data well and accurately. And that gives us good methodological power. So if I want to make a statement about how people interact, I need to be very clear about the thing that I am looking for, and then very precise about the way I gather that information. That allows me to say with a good deal of accuracy, this is actually how people are responding. Now, that can get very complicated very quickly, and so a good theory and good research exhibits the quality of parsimony. And this is a combination of precision and power. I want to be precise, I want to be powerful, but I'm as detailed as I have to be, but I am aiming for being concise. Sometimes you can see a theory or research and it's just very convoluted and very confusing, and that's not super helpful, right? So for instance, if you ever picked up a recipe and it involves 45 steps and you got to think, there has to be a better way of doing this. Is it really that complicated? That's what we're looking for in parsimony. Is it as complicated as you say, or are you adding things that maybe don't need to be there? So sometimes what we're looking for is how can we make our explanation as simple as possible? Maybe these things kind of play a role, but do they really? And can we get the simpler explanation by taking some of the extra stuff out? So simpler is better, but only simple to what is actually needed. It doesn't mean that you exclude things for the sake of excluding things. Now, one of the things we want our measures to be is reliable. They should perform the same way again and again and again. So you can see in the image here this idea of reliability. So if you had a target practice, you were throwing darts or something, right? You want your results to be tightly grouped around the target so you have consistent results. So if I am trying to hit a bullseye on a dartboard, I am around the bullseye consistently. Now, that doesn't always happen. Sometimes things go astray in research. It can come down to data entry. It can come down to people being confused about what you're asking on an instrument, random human difference. People read a sentence and got something very different about it. But if we have 100 people and 5 to 10 maybe got confused or number got mixed up, we're still 90% accurate. We're pretty happy with that, right? So we want to aim for more consistent, more reliable measures so that over time we're going to see the same thing. Now, there are a couple of ways that we can make sure that we do that, and one is this idea of intercoder reliability. This is an analysis of how different coders are looking for the same thing. So if I were to show you this picture, and I would ask 3 raters to tell me what it is, 2 of them said dog, 1 said fox. Okay, 2 out of 3, right? And maybe consistently we seem to find that, and that doesn't seem to be a problem. But every time I show a dog, Rater C keeps calling it a fox. Well, that allows us to see that there's a consistent problem happening in our data analysis here. So coder C seems to not know what a dog is. So we need to go back to talk about what we are looking for to identify a dog versus a fox. So it comes down to that conceptual power, being clear and precise in our definitions to allow someone to go code something so we can be reliable in our measures. Other things that we can do, we can look at alternate forms, like using 2 or more measures to measure the same thing. So there's lots of ways to measure something, and so maybe we try a couple of different attempts and we can see, yeah, this seems to be measuring the same thing pretty reliably compared to other tools. And so what we want to see is, are the scores pretty much the same if we use different kinds of measures? Maybe I use observations, and maybe I use a survey. Maybe I ask you a different kind of survey that should be asking the same thing, and we get some similar results. Another useful tool is just the test-retest. I just give you the same measure multiple times. So if I am measuring your sense of humor at time 1, your sense of humor probably isn't going to change drastically in a couple of weeks. And so if my measure was actually measuring sense of humor at time 1, then I should get pretty similar results at time 2. So the results shouldn't change from time 1 to time 2. So if you are reading my questions and I'm getting accurate results, then I should be able to see that same kind of accuracy at time 2. Now, all of that is thinking about how reliable or accurate, but we can be consistently measuring the wrong thing, and that's where validity comes in. So is our measure measuring what we say it does? So we can think about the content, we can think about the questions, and we can use criteria to make that determination, but what it comes down to is I could consistently miss the target, but that doesn't mean that I am actually going towards the target. So if I say I'm measuring how well I can throw a dart at the bullseye on a dartboard, and I throw 20 darts and my darts are really tightly grouped together, they're all within an inch of each other. I am remarkably accurate and consistent, but I didn't hit the dartboard at all. Well, that's not very valid, is it, right? So I want to make sure that what I'm actually measuring is the thing that I'm actually attempting to do. And that's why some of those alternative measures come into play. And really looking at the questions. Am I actually asking the question that gets at what I want to know? That's what validity is all about. So moving on to hypothesis and research question testing. So as good as our ideas about variables can be, and as good as our measurement can get, all of this comes down to what do we do with those measures and those variables. So what we're attempting to do is to think about how dependent and independent variables come together and interact with one another. So we think about the dependent and the independent variables like this. The independent variable is something that changes. So it may be something that is naturally occurring that changes. It may be something that we might implement a change in. So in an experimental condition, I might give you a message versus someone else, I might give a different kind of message, right? So that changes. And what we look for is the dependent variable, and that is the outcome. What happened when I did something? So this is a really good example of thinking about the independent variable of the amount of sunlight that a plant receives. I can vary that. I have a couple of windows that get a lot of light and a couple that don't. And if I move one plant to the other window, does it do just as well as it did before, or does it need to go back to the window where it got more light? And so I can look at the plant health. I change location, I change the amount of sunlight, and therefore I can see the impact that it has. Now, when we think about human communication interactions, sometimes the independent variable isn't as obvious. That can be as simple as the number of times I ask you a question. It can be as simple as the word choice that I use. It can be saying something to you at all versus not saying something to you. It can be, where do you look for support when you're feeling bad? Do you ask, who are you asking? Right? That can be an independent variable. Are you asking your friend? Are you asking a therapist? Are you asking your parents? Are you asking a romantic partner? Are you going online in chat groups and finding support? Those are things that change. The end result is still, how are you feeling? And that can be the dependent variable. That's the outcome. So when we aren't always certain about the relationship between the independent and dependent variables, sometimes we'll ask a research question. And this is often the broad question we might have. It's just, what is our study about? What's the focus? What do we want to answer? What do we really want to know? So what's the big picture here? And all of this is going to be based on research. It's going to look for relationship between variables. So I know that these things tend to happen. What is the relationship between the amount of sunlight and a plant's health? Can you have too much sunlight? What is the maximum amount of sunlight that can be provided to a plant before it becomes a problem? Does the age of the plant matter? Right? These are questions that you have. You don't necessarily have a way to know the answer yet, and so you would simply ask the question. If we're a little bit more confident, there have been some more observations, we can move on to a hypothesis. And this is a statement that we can go test. Am I right or am I wrong? I make a prediction. I think that if we do this, then I get this outcome. If I put my plant in the closet for 2 weeks, it's going to die. I can test that. I can take my plant and put it in the closet and come back in 2 weeks and find out, was I right or was I wrong? And so I have a problem in front of me. How much light do I need to give this plant? And I can go find out. If I can give it this amount, what happens? If I give it this amount, what happens? If I give it another amount, what happens? And what is the conclusion that I get? And then I can have a little more confidence, and I can go and revise that hypothesis and come up with different versions to test. So what we end up doing when we are engaging in hypothesis testing can be a little bit confusing, is that we are testing the null hypothesis. We are essentially saying, is there a relationship between the variables? So when we engage in hypothesis testing, we don't find that we were right, we just learn that we weren't wrong. So if I think that my hypothesis is, if I put the plant in the closet for 2 weeks, it will die. What I want to know is it still alive? No, it's not still alive. Well, putting it in the closet doesn't keep it alive. So the null hypothesis is testing that there's no relationship between those variables. And then a hypothesis will tell us to what extent there seems to be evidence to support that there is that relationship. Now, when we get into research hypotheses, we can have a couple of different ways to phrase them. I'm going to talk about the wording of them in just a minute, but we can have a non-directional, directional, or a causal hypothesis. A non-directional is exactly as it sounds. We assume there is a difference that exists in variables, but we don't know what direction. We just know that these coexist. We tend to see these at the same time, and my prediction is that that is not random. It is consistently these two things seem to happen. I don't know what one cause and the other, it's just both of these happen. So it may be the number of times you talk to a romantic partner and the feelings they have for you. I assume that's related, right? Their feelings may lead to them talking to you. It may be the amount that you talk to you leads to your feelings one way or the other. It's hard to say. But if we have a little more confidence about maybe which is causing the other, or we're not really sure, we might say it's directional. In other words, we might say that I know that the more I tell you I don't like you, the less you seem to like me. That seems to be a pretty consistent relationship. And so I can say that as one thing goes up, the other thing goes down. So there is a direction to these relationships. But I might say, both of those two just say that these things happen. They don't really say that one creates the outcome. And so I might want to make a causal statement. I might say a cause and effect relationship. When this happens, this other thing occurs. So the non-directional is that if these things happen, they seem to occur at the same time. The directional says that they occur at the same time, but as one thing goes up, the other tends to go in a particular direction. We get more of the same, more or less of the same. And causal relationship says that it's not just random co-occurrence, that this thing creates that. It is a sequence that occurs. When I do this, then this other thing happens. Now, a good hypothesis will have a couple of things to it. It's a declarative sentence. So, and it seems like you shouldn't have to say that, but it is a sentence. It's not a question. And it describes the relationship between two or more variables that is based in literature. And we want it to exhibit that quality of parsimony. It shouldn't be too long, shouldn't be overly complicated, and we should be able to test it. So the hypothesis might be something like the amount of times we remind each other of shared experiences, the more positive feelings I have for you, right? If we talk about good times together, then I like you. That makes sense, right? I can measure that, I can test that, I can observe it, and that's relatively straightforward. Good research questions aren't that far off. Again, it's the form of a question. A question should be a question. It is about the focus of the study. It's based in literature, and again, it's not too long. So let's look at a couple of hypothesis examples and see if these are actually make sense. So ice cream melts faster than ice. So is that a good hypothesis? Well, I would say yes. We can see what is the variable at work here, right? How fast does it melt? We're comparing ice cream and ice. We can put some ice cream and ice and start a stopwatch and see which one melts faster, right? That's testable, it's observable, we can do that. Number two, will fertilizer make my lawn grow? Is it a good hypothesis? No, it's a question, right? It's a fine research question, but it's not a hypothesis. 3, Pepsi is better than Coca-Cola. No, not a good hypothesis. It is an opinion. We could say that Pepsi is preferred by more people than Coca-Cola. We could go test that, but what does it mean to be better? Right? That is undefined, and we can't test that. That is a personal preference. And the last one, working hard, being nice, and making good choices will make me a better student. Is that a hypothesis? Now I'd say yes, we can test that. We can measure what it means to work hard. We can measure being nice. We can measure making good choices. Will that make you a better student, right? We can measure all of those things. Is it a great hypothesis? I wouldn't say so. What does it mean to work hard? What does it mean to be nice? What does it mean to make good choices? What does it mean to be a better student? What do these things mean? So this is a good example of having that conceptual precision being laid out before you make the hypothesis would be important.